completion of this session, and there is a question answer. Okay.
I have been told
Okay, welcome, sir. Welcome.
this party of composition has carcinogenic properties, and that is why European countries are moving away from this.
But main advantage is with this NHN detonator, you have completely replaced the ASA. So that is why, and moreover, I found that they have already produced 50 tons of NHN, and there has been no event of any accident, and more of 150 million numbers of NHN detonator you have produced with no press fire. I think looking to this, it's a very good achievement, and thank you very much. Now, I would request the last speaker of this session, Dr. Agarwal. I would request all of you to bear with the time because although I have requested Dr. Agarwal to finish within 10 to 12 minutes, but bear with us, he will do that. So Dr. Agarwal, he is going to make a paper on present need for low, vulnerable and high performance energetic materials. Dr. Agarwal, after acquiring his academic qualification, he joined HEMRL and worked on development of high energetic coordination complexes, which includes detailed study on synthesis and characterization with the thermal properties with electrical mechanical stimuli. He has over 37 years of experience in the field of explosives. After his retirement from HEMRL for 2 years, he worked with DGOF Pune for development of eco-friendly and low vulnerable detonator number 27 and 33. Currently, he is working with Solar Industries India Limited. So, Dr. Agarwal, please make your presentation.
Okay, respected Chairman and high dignitaries and delegates and friends. This is a new topic. So far you have listened a lot of merits and demerits as far as the conventional initiatives are concerned. But this is a present need of low vulnerability as far as concerned with the initiatives. I will speak especially for the initiative purpose. Because of their initiation power, the compounds are very sensitive and impact and fraction sensitivity very high. So vulnerability is questionable for the manufacturing of explosive pertaining to civil and military purposes. So this my presentation will be on need of low, vulnerable and high performance energetic material. This topic will be covering introduction first. I will just explain what are the shortcomings in present primary explosives and the background how I selected this research as for the explosive coordination complexes. The merits of BNCV which has been produced, that also I will discuss, and result and discussion and conclusion. Now, as you know, the explosive, it is a storehouse of energy, and this storehouse of energy is maintained under equilibrium. The potential energy, binding energy, translation energy, binding energy, all energies are compact into a house and maintaining the equilibrium. Once the equilibrium gets disturbed by the extra stimuli, these molecules undergo a hazardous rupturation. And this hazardous rupturation is in the figure like this, is given giving the temperature of very high of 3000, the pressure which is 12,000 to 15,000 more as original one, a light with a fraction of seconds. So it's a very sustainable, but within the seconds, this all system undergoes into the hazardness. Now, conventional initiatory, you will be well known to it, is the main important aspect as far as the detonators are concerned. As you know, the detonators is the first firing element which initiate your rest of the explosive train, and these detonators, if testing is required, it is a zero tolerance, means 100% you should get the output. Even thousands of detonator once fire, there should not be any one misfire. Therefore, it is categorically, it is very important as far as the compositions by which the detonators are pressed. The composition, therefore, the lead azide, lead stiffenate, mercury fulminate, tetrazine, these are the well-known initiatory last 8 decades. And these initiatories have got very important property, very nice property of ease of ignition. It ignites very fast. So this better property, the detonators are developed. But with the good property, there is various demerits includes in this, because it's very sensitive, vulnerable due to the mechanical stimuli like your friction and impact. And next is, it is moisture effective. During storage, moisture imparted inside, it undergoes a very hazardous reaction produced, as my previous friend has stated, the formation of active SCN. And this SCN react with the hardware of detonator containing copper and form the very hazardous material like copper azide. Therefore, the researchers all over the world, they were having continuous efforts how to replace these metals. In time to time, they have desensitized these material, especially lead azide, by the different additives, destine, polymeric material like CMC and PVA, to reduce the vulnerability, and has been used in the manufacturing of explosives pertaining to the military as well as the civil applications. So these are, I will give you an outlook of it. These are all used in the ordinary ordnance community and civil sectors. Have got the, as I told you, the serious drawbacks. It's not eco-friendly because of the 80% lead is available in this amount. Somebody has asked about the NHN. Of course, I may not be repeat the same thing, but NHN carcinogenic nickel, but the quantity is very less. It does not affect the environment much way. Anyhow, our HMRL has done a very, very important work regarding to reduce the sensitivity of LA by embedding the basic moiety in the molecule, by lead azide molecule, form the BLA. And basic lead azide has drastically tested in various detonators and found suitable to replace the service lead azide. At present, in the ordnance and as well as civil sectors, they are using BLA in place of SLA. But however, all difficult drawbacks, demerits, which are very dangerous in the storage as well as the transportation. Therefore, the researcher all over the world, they want to divert their attention not to think about the present conventional initiative, to go for the different direction of this coordinate compound. Coordinate compounds is really, just I will give this background of the present study. In 1986, just I was searching the literature, found the Americans have done a very excellent job preparing this CP as a coordinate compound, and CP compound has replaced completely your lead azide, lead stiffenate, and aluminum base. Only single compound is sufficient to use for initiation the rest of the booster charge. So this has influenced me to go under detailed literature survey, because in those days, literature survey was by journals and all, we have to look into that matter. So a lot of data were collected, but found scanty scanty literature as far as the, this preparation is concerned. Therefore, this project was given to me, and I had done an elaborate study by synthesizing about 20 to 25 compounds with the different ligands and different oxidizer ions. I will just give you an outline of how this works. This is the main inner atmosphere and outer atmosphere. Outer atmosphere containing your oxidizer ion, and inner sphere, it is based on the transition metals having the coordination number. And that coordination number, the pair of electron from the ligands, generally ligands are nitrogen, oxygen, sulfur containing, they are called as ligands. So a pair of electrons resemble with your central atom. The central atom of a coordination compound is very, very important regarding the performance-wise. Of course, this synthesis, during synthesis, characterization, the vulnerability was very low, means very safe in handling. During processing, nothing, it were very safe. I have done some elaborate study. I found the transition element, iron, nickel, iron, cobalt, nickel, copper. Out of this, the cobalt and nickel found to be a very good central atom, which will not only give you the catalytic action on the molecule, but it will give you the stability of the molecule. How the stability of the molecule will obtain? Because they were octahedral type of molecules. They have the chelates. The one ligands up and one ligands up. This is in the middle of. So chelating is giving these cobalt and nickel. Therefore, I have selected only cobalt and nickel. Of course, I have done some study with the copper also. Sir, this will be very difficult anyhow. The fundamental reactions. This is the fundamental reactions. This is a synthesis of VNCP. Okay, I will do finish it. Okay. Then characterization has been carried out very vastly by using the ESCA, SAM, FTIR. All this data has given me really a boost to make a structural confirmation with the elemental analysis. And the BOD was also calculated, even though, as you know, there is only two aspects of initiation, by the electrical initiation or mechanical initiation. But nobody has studied so far that SCB initiation and the laser initiation. I have elaborated my study by using the semiconducting bridge connections in spite of electrical, and the laser, carbon dioxide laser has been used for my all 25 synthesized compounds. This is the elemental analysis. This is the figure of FTIR. These are the group frequencies. And the property, if you will see it, I will speak about the BNCP. Rest of the things I will show you when the carbon dioxide laser initiation will there. The physical and bulk density deflagration is mentioned, and impact sensitive, very, very insensitive as far as the 50% of impact is concerned. And friction sensitivity is about 3 kg. See, as far as your other lead azide and lead stiffenate, you will see it will be in the gram. But these compounds have really a very safe up to 3 kg. Now, this is the compound. What I was talking about, the chelating. the one group up and one group down, and between this central atom cobalt is. This confirmation I have done by ESCA. And in ESCA, binding energies with the ligands and cobalt I have studied, and I found this type of surveys. These various compound which has been synthesized by me, nickel of one is hydrogen hydrate, which my friend has already described. I have done further study with the carbohydrates. Carbohydrates are is the very good ligand when well attached with these transition elements and gives a very good sensitivity. I am taking some very fast, no problem. These are the structural, these are the same scanning electron microscope has been studied. And this is the, I have studied the comparative study with BLA. I have selected only BLA because presently the BLA is used in place of SLA. The NCP, these are the different compounds, coordinate compound I have studied, synthesized. The thermal stability of this NCP is nickel carbohydrate perchlorate. Actually, perchlorate is superior oxidizer than sodium nitrate. Sodium nitrate is a weaker one, therefore, you are getting somewhat lower BOD. But in case of the perchlorate, the BOD is higher. So perchlorate was selected. Ignition temperature is given like this. The NCP is having 332. Now bulk density is even NCP is higher. Then sensitivity, these are all figures again he will be okay. Then this is the explosive characteristics of BNCB, which we can, if at all you need any query, I will definitely after lecture will be able to give you details. This is the concept, general concept, how we have gone through with the synthesis of different ligands with the different central atom, with the different oxidation ion. This is the general replace. Now, differential scanning calorimetry has also been studied. Now, this is with the Ozoa and Kissinger method. I have calculated the activation energy, found very nice, 32 kilocalories per mole. Now, variation in temperature, these are the calculation for energy. This is, now, XRD has been carried out just to identify the A, B, C, or D, this thing, and then compare with the standard values available in the literature. These are the things which I have done it. Now, this is the ESCA, electron spectroscopy for chemical analysis. This is the elaborated term. This will give you the binding energies consenting with your central atom as well as the ligands. So, by which you can select, yes, our ligands are, how many ligands are attached with the central atom. Now, this is lead-free advantage primary explosive. This is the BOD and all figures I have given. Now, after doing all this thermal analysis and characterization of all compounds, some of the compounds I have taken for the functional test, filling into the detonators in the ammunition factory, Karki, Pune. And in that, I compare with the present available detonators consisting of ASA composition. See, when this BNC was mixed with the lead azide, it has not shown any function. But BNCB with NHN, it has not shown any function. BNCB with NCP, carbohydrates compounds, they have shown a 9 mm deep in a lead tube. Sir, acha, okay. Okay, this is this. These are the carbon dioxide laser initiation. See, first times in history we have, I myself has done it, this laser initiation. And in the laser initiation, I want to just take some minutes. These are the things which we can pass, and this is the. See, in laser, this is the functional time, initiation behavior, and this ignition period, and the thermal energy. Actually, you just see the different coordination compound have different functioning time. Rather, you can say ignition delay. And found BNCP is 75, while in case of the NHN, it is a quite sensitive with the laser, 26. Anyhow, these are the things which, this is the last, I want to just keep aware that nowadays, this NO2 group, if at all you can detect, but peroxide group you cannot detect. It's a really and it is a very good explosive. So I don't know why the explosive community is not considering this compound is very nice compound. Thank you very much, sir. Thank you very much. Thank you.
Thank you very much, Dr. Agarwal. I am very sorry that I had to request you to cut short because although I found your paper was very much interesting and you have developed a lot of energetic materials by virtue of your experience in HEMRL and very nice, we have been rather benefited.
Sir, 1 minute I will take. I will thanks my economic explosive chairman, sir. He has given me opportunity to come on this dice. I am thankful to.
Very nice. He is here.
Thank you. Anything you want?
Thank you. Yeah. No, there is going to be. Thank you very much, Dr. Agarwal. I will also put a question in for your paper. Out of just for your information, out of NHN and BNCP, which is a better primer. Anyway, but now I would request this is going to be question and answer session. Anybody who wants to put any question to the speakers, so please write down in the slip and slip will come. I will be permitting only 2 questions per speaker. If at all questions are more, those can be discussed later on during the lunch time and all that. So the first slip I have already received from Mr. Sridharan from Ganesh Explosive for Dr. A.N. Gupta. So I am giving this question to him, he will answer it.
So the question is from Mr. Sudhakar. Okay. And the question is there any replacement of ammonium perchlorate in the manufacture of solid propellant? Yeah. Solid propellant ammonium perchlorate has been used for a very long time, but it is certainly not environmentally friendly. It gives hydrochloric acid gas on combustion, and there is a chemical called ADN, ammonium dinitride, which has been found to be the green propellant oxidizer. Again, this has been developed by Vikram Sarabhai Space Center. We have obtained the technology on gram level, but it is very difficult to scale up. So we have not been, but we are at it. Yeah, ADN can be used for the replacement of ammonium perchlorate.
Thank you. Is it commercially viable?
You see, once we are able to make larger quantity, we'll be able to say whether it is commercially viable. But certainly ADN is used by some of the manufacturers abroad.
Any other question to Dr. Gupta? No. Then, Dr. Gupta. Yes, please. You want to ask question to Dr. Gupta? I'm coming to that. So next speaker for Mr. Jain. So please ask Mr. Singh.
What is this percussive pulse? Is it percussive?
Wave.
Percussive pulse wave.
Yeah.
Is it percussive? How it is percussive?
Pardon?
You use term percussive pulse propagation in your shock tube.
Right.
How is it called percussive?
How is it called?
Percussive.
It is named this shock wave generated. It propagates in the forward direction.
This is a pulse,
Yeah.
moving at VOD.
Right.
How is it called percussive? Percussive means continuously pulsing.
Yeah, it is pulsing.
It is moving at the same pressure,
No,
and then there is a back pressure following. How it is called percussive? That's what my inquisitiveness to you is. And
well,
up to what maximum length this shock tube can be used for long hole blasting?
we have used up to 6,000 meters.
6,000 meters.
Meters we have used and it worked well.
No, in one hole.
One
How much?
hole. No. We measure when we are making 3-layer shock tube, and once because the one spool length initially it was a 6,000 meter, and we try to initiate that one. It worked well. Number of times we initiated 6,000 meter spool and it worked well.
Okay.
Above that we didn't test.
Okay.
And 3,000 meter is the normal.
Then one question to Professor Kumar. You have worked for this all chemistry and control of this reaction, chemical reaction of high energy materials from batch to continuous flow. Can you tell us how can we control the explosion reaction so that it can be used? Suppose we want 10 minutes time for explosion, 20 minutes time for explosion. Can we do this?
That you have to change the chemistry. So same
That is
material.
what I am asking from you.
Yeah, so work has to be done, and there's nothing impossible. If there's a wish and there's a person working and there's a requirement,
This
there's a
is-
lot of substitute known, and one should be in a position to change that.
This is
Effort
the
has
wish.
to go.
This is the wish for mining industry. Basically.
Sure,
We want 10 minutes
Yeah.
explosion time.
it won't come free. So if you are ready to put money, there are good scientists available in the country. Free won't be available. So if you
But
are
for mining community, at least you should show us something, some example. Government will pay money. There is no
Yeah,
problem for
but
money. But
I'm
we want
not,
results.
I'm not the expert in everything, but I'm sure there are good scientists available in the country. If there's a right requirement and the priority, there's a solution for everything. But there could be other pressures to do something else. That's the reason it has to be motivated and the resources should be there. There is no dearth of manpower in this country, I can assure you that.
Okay, thank you, sir.
Any other question to any speaker in particular? Yes, please. Your name, please. First.
My name is Vidya Sagar from Ideal. The percussion may not be propagation in fact. The percussion may be for the initiation of shock tube. The percussion method of initiation. It is not propagation. The percussion caps are there. Percussion systems are there that help. There are variety of initiations for shock tube. Percussion wave is one of the initiations. That is what we know.
Yes,
The other thing
yes,
is
yes,
that
yes.
the demand for a detonation or explosion has to be delayed for 10 minutes. Probably theoretically it is not possible because after all detonation or the rock fragmentation are happening because the energy is being released in a moment of time, in a fraction of second. Because of sudden release of energy, that to high energy, the detonation is taking place. If you delay it for 10 minutes, probably, rock fragmentation may not take place. This is at this point of time, I would like to say. At this point, at this stage of research, I would say. Thank you.
Any other question for Dr. Rao or you? Your good name, please?
I'm D. Mandal from Indian Oil. My question is to Dr. A.K. Jain.
Okay.
Actually, sir, you have talked about shock tubes, sir. In the case of charging watery holes in the field, how many sleeping days period do you recommend while charging with the shock tube? Because in some cases we have seen there has been ingress of moisture with the period, if the sleeping period increases.
Depends on the number one type of the tube. Like suppose if we are using a 3-layer shock tube, okay. Normally we have tested at a temperature about at 60 degrees centigrade, and we have kept that shock tube for 45 days. After that, it it went off very well. Even we have put this shock tube in oil, and for 2 weeks there was nothing wrong in that. And after 2 weeks, that depends also in the type of the shock tube you are making. the percentage of the saline, the first layer you are using in that. Like now being costly, sometimes it is being used 20%, 30%.
Right.
And we have seen some imported shock tube also, even they are using even up to 50% saline, that is the first layer.
Right.
That layer can be kept for month, I think.
That, thank you.
Anybody else? Any question for Dr. Agarwal?
For me, I feel either my subject has not been interesting, or I think it will have
Then I will put one question to you, which I have already mentioned. And out of NHN versus BNCP, which is better? Any study has been done?
neither it is a moisture affecting, it is a very stable compound. It goes up to 260, there is nothing will happen. And it's as far as the impact and friction sensitivity is concerned, it's very insensitive. And most important factor, it is a eco-friendly in nature. It's a cobalt is there, of course, but it is about 4%. It does not matter much. So BNCP is supposed to be in the future. I feel so the people will like it. It's a very nice compound.
Thank you.
Explosive coordination compounds. CP, I told you, in the beginning itself, I got the enthusiasm from CP. CP is one of the, if at all you want a structure, I can draw the structure. CP is nothing, only in its place of nitrate, NO2, they have linked with the cyanogen, CN. That is only difference. Otherwise, BNCP and CP both are same. Sir. Yeah. So, NHN have got their own drawbacks. That is different. Right. Yes. BNCP nowadays, I think so, it will come in future in India also. It has already developed in China and in America. Both countries are using very high. Okay. Oh, thank you very much. Nice of you. Okay.
Again, looking to the time constraint, whatever questions are left behind, I would request that can be discussed in the lunch time. Then it is only last. No further extension. After that, I will be handing over to young lady who has handed over this mic to me. So last question. Yes, please.
Is sold in paise, 300 to 400 paise, and we are talking of some technologies where the cost may increase by a few paise. In our country is most critical. I think the first law the government of India should pass is no detonator shall be sold at less than 20 rupees. That will avoid a lot of misuse. I'm asking all, you as well as NHN, Dr. Rao. And the other question I would like to ask you, sir, is what about the reproducibility of the process? Because in industry, we want a process that is reproducible and stable, and what about the shelf life?
Sir, These all characteristic properties has already shown here.
Right.
These shelf life is very high. See, this compound will give you the definite detonator shelf life very high. I am assuring you. But cost effectiveness there. See, the cost effectiveness is there. But no detonator will have the storage hazardness. No detonator. This I can assure you, this BNCP. Once it will come, you will feel, yes, this is the compound which will be enjoyable with the detonator. Thank you very much.
Okay, thank you. I think you are satisfied with his answer. No, you should be satisfied. I can only add one word, whatever you have suggested, the cost of a detonator to be 20 rupees. I would request you to find out who will be the customer then. Who will purchase a detonator costing 20 rupees? So now thank you very much for all this question answer sessions. And now I'm handing over mic to organizers. Madam, please continue.
Thank you, Sri Nigam, for chairing the first session of our technical day 1. I would also like to thank all the speakers who have made their presentations today and the audience for the wonderful interaction. I would request our chairperson, Sri A. Nigam, to present mementos to all our speakers. Kindly present the memento to Dr. A. N. Gupta. Sri Nigam would now present the memento to Dr. A. N. Gupta. Sri A. K. Jain. Professor Anil Kumar. Dr. N. V. Srinivasa Rao. And Dr. A. P. Agarwal. May I now request Mr. B. K. Paul from Special Blast Limited to present a memento to our chairperson, Shri A. Nigam. Let's give our chairperson a round of applause. Thank you very much. Ladies and gentlemen, we shall now break for lunch. It's going to be a 30-minute break. May I please request everybody to proceed to the lunch setup which is awaiting us. However, please be on time so there is no delay in our second technical session. I would request everybody to adhere to the time schedule and also the second session speakers to come ahead and meet us at the technical console. I would request Sri Rakesh Kumar, Indian Explosives, Sri A.K. Srivastav, Solar Industries, Sri T. Vikram Sarabhai Space Center, Sri G.N. Siva Prasad, Ideal Detonators, to all come forward and meet our technical console team. Begin with our second technical session in about 2 minutes' time. May I request everybody to take their seats so we can quickly begin our second session. Super Shiv Shakti Explosives Private Limited to welcome our chairperson Sri A.D. Sao with a floral bouquet. Mr. A.D. Sao is a 1978 batch B.Tech degree holder in mining engineering from the Indian Institute of Technology, Kharagpur. He secured gold medal in Bachelor of Law. He started his career in the marketing department of the Easterville IDL Industries Limited and held several senior positions in the organization. He has been actively associated with the explosives industry in India for the last 38 years. He has been awarded with Lifetime Achievement Award by Indian Mining and Engineering Association. He is currently working as the Chief Operating Officer of IDL Explosives Limited. May I now call upon the speakers for this session, Shri Rakesh Kumar, Indian Explosives Limited. Shri Rakesh Kumar. I would request Mr. R.B. Kota from Deccan Explotech to welcome Shri Kumar with a floral bouquet. I would now call our next speaker, Shri A.K. Srivastava, Solar Industries India Limited, Nagpur, to come to the dais. Yes, we can definitely give them a round of applause. There's no harm in that. I would request Mr. G.C. Mathur from Aravali Explosives to come to the dais and welcome Shri A.K. Srivastava with a floral bouquet, please. I would now request Shri T. Vikram from Vikram Sarabhai Space Center, ISRO, Thiruvananthapuram, to come to the dais and join us. And also request Mr. M. Rajkumar from Raja Explosives to welcome Shri T. Vikram with a floral bouquet, please. I would now request Shri G. N. Sivaprasad, Ideal Detonators, Sikandrabad, to come to the dais and be amongst the speakers for this session. And I request Mr. Subodh Prasad from Prasad Explosives to come up to the dais and welcome Shri G. N. Sivaprasad with a floral bouquet, please. I welcome our chairperson and speakers for this session and request Shri A.D. Sao, Ideal Explosives Limited, to chair the second session of Explosafe 2016, which is Hazards in the Manufacture of Commercial and Defense Explosives. Thank you.
Good afternoon to all. I hope you had a sumptuous meal, and this session, very interesting session as it is, will keep you awake after the meal. So we are already behind schedule by over 35 minutes. So I'll request each one of the speaker to restrict their timing. And after 10 minutes, I'll give a ring. And after 13 minutes, I'll give another ring. And I request that by 15th minute, they will wind up. And try to be as precise as possible. And question answer series also, we would like to maintain, and we'll at least, one thing I can assure you that I, not being expert on the subject, will not give too much of expert subject, so expert comments. So the time should be restricted, that I will ensure. So first I invite Shri Rakesh Kumar. I'll introduce his paper is on safe practices during manufacturing of initiating system. Shri Rakesh Kumar is a mechanical engineer and 7 times winner of Star Performer Award for Innovation in Sterlite Optical Technology Limited, Vedanta Group, in the tenure of first 6 years of profession. He has over 15 years of experience in operation, projects, engineering, maintenance, and utilities. He had filed 2 patents for innovation in optical fiber process technology. Currently, he is working in Orica Gomia. I welcome and request you to kindly put your presentation.
Good afternoon to all. First, I would like to thanks to Explosive Manufacturing Welfare Associations and the PESO organizations, which given me the opportunity to come on the decks and give some thoughts in front of the intellectuals, people who are sitting in this room. So thank you. So my topics, when I'm looking the first session was full technical, the full thoughts of the chemistries, the scientist thoughts. But my topics is a little bit related to the human beings. So what is my understanding on this safe practices during the manufacturing of the initiating system is, one of the important factor is playing a big role, a key role in the safe practices during the manufacturing of initiating system is the human beings. So I will talk on the human being, systems, people's training, competency, leadership related to the safe practices during the manufacturing of initiating systems. As organizations, Indian Explosive Limited, we always believe in safety, and our value systems is driven by the safety. Our business is driven by the safety. And so that one of the value of our organizations is no accident today. The thoughts behind that, what we are thinking, if there will be no accident today, maybe then futures will be, of course, very, very clean, and we can achieve the visions, the zero accident. So that's about my organization's belief and the value of my organizations. The content, basically I will talk about the process safety management systems. This is new technologies and thoughts of the risk assessment, which is called the control-centered risk intelligence. This job cycle check, incident management, emergency management, management of change, product stewardship, and competency and proficiency. All will related to the human psychology. In the safe practices of the manufacturing of the initiating systems. Regarding the introductions, first I will try to give the typical definitions of the initiating systems. The initiating system and accessories are used to initiate the explosive reliably from a safe distance at a designated time and in a predetermined sequence. This is the definitions we believe of the initiating systems. And as we all know that the initiating system manufacturing consists of handling the primary explosives like the leadite, lead stiffness, secondary explosive, PTN, TNT, HMX, intermediate process like the pyrotechnic, fuse head manufacturings, shock tube manufacturings, and the final products. When we talk about the initiating system, the final products like detonators, the Primus boosters, the detonating cords. So these are the overall the manufacturing system in the initiating systems. Initiating, as we know that initiating systems are vulnerable with respect to the phase events, phase, friction, impact, static, and heat. So these are the 4 important steps related to the manufacturing of the initiating systems. And this implies need to have a thorough safety management system underlying the manufacturing of the initiating system and the accessories. The rest of the slides will try to cover on the safety management systems, which is important for the safe manufacturing practices in the initiating systems manufacturing. Now, the process safety management. Generally, in industries, we are giving too much focus on the personal safeties. But if you look at the history of the major disasters which had happened in the explosive industries, or chemical industries, the major contributory factor which we found is the process safety, So now, that's why our paper has started with the thoughts of the process safety management. The definition is very, very clear. A management system that is focused on prevention of, preparedness of, respond to, restoration from the catastrophic release of chemical or energy from a process association with a facility. In simple language, what we are defining the process safety deviation is any deviations out from the safe operating window where we are handling the energetic material, we are calling as a process safety deviations. And the process safety management focus on the preventions of the low likelihood but consequences events like the explosives. Particular in IS manufacturing, initiating system manufacturing, the process safety is very, very important stuffs. And the evaluations of the process and the safety start from a standard-based strategy, compliance-based strategy, continuous improvement strategy, and risk-based strategy. And these are the 4 important pillars for the preventions of the incident at a risk-based appropriate level. One is commit to process safety, to understand the hazards and the risks, learn from the experience, and manage at risks. And there are 19 elements which are divided into these 4 important pillars of the process safety. When I talk about the first pillar is commit to the process safety, here we are talking about the process safety culture, compliance with the standards, process safety competencies, workforce involvement, and a stakeholder outreach. The second, when we talk about the understand the hazard and risks, here we are talking about the process knowledge, hazard events, and risk analysis. When we're talking about the learn from the experience, here we are talking about the 4th element, incident investigations, measurement and metrics, auditing, and measurement, review, and continuous improvement. And the last, which is very, very important pillar, is the manage risks. Here we are talking about the 9 steps, the operating procedures, safe work practices, asset integrity and reliability, contract management, training and performance assurance, management of the change, operational readiness, the conduct of operations, and emergency management. These are the 19 elements which is broadly come under the 4 strong pillar of the process safety management, which is really helping in preventing of the incident at the manufacturing stage in the initiating system process. Then, one of the component of the process safety is the basis of safety. And what is basis of safety? Very simple definitions, which generally we are talking in the industry is the preventions of unplanned explosions, fume off, and fire specific to the explosive industries. It is the corporate memory of the organizations painfully learned from the past events. And it is the identify hazards and defined control of each our process. And the most important line for the basis of safety is the basis of safety fits as a base for all other process definitions. So when we are talking about the initiating systems, when we are talking about the manufacturing of the initiating system, these are the base things, basis of the safety, which I talked at the beginning, the phase, friction, static, heat, and impact. Now, these are the inputs. If it is center, the set of the guiding principle for the basic of safety is, what are the input for the basis of safety? Risk identifications, the technical corporate memory, and the incident learning. These are the input for the basis of the safety. What are the outputs? When I am talking about the outputs, the output is the minimum design standards, the minimum engineering standards. Very important parameters, word, which is always keep in our memory in defining the standards and engineering is the minimum. So at least we have to focus on the minimum standards. So the output is the minimum design standards, minimum engineering standards, minimum operating procedures, the PHS, training documents, the process, the operational checklist, and the technical audit checklist. And for every output, there should be key accountability should define in the organizations. Now that's another pictorial representations for understanding the BOS. What are the cause? Cause in terms of the frictions, static, heat, and what are the controls we are talking about? And then the incident is taking place. And the important part of the incident is the mitigations. How we are giving focus or attention on the mitigations control, like the quantity distance and the emergency response plans. So these things is very, very nice. Pictorial representation is very simple things to understand the people which are working in the IS world. Another important parameters for the initiating system is the hazard study. Hazard study we are generally doing for the new facility, and the periodic hazard study we are doing for the old facility. The purpose of the hazard study is identifications of hazard, eliminations of hazard, minimizations of potential consequences, meeting the legal requirements, installations of the correct equipment, achieving the design intent. These are the main purpose of the hazard study. Next we'll go to, and the next slide is giving the, at what stage we have to apply the different of the hazard study. Hazard study, generally we are doing HS6, HS1, HS2, HS3, HS4, HS5, and HS6. And HS1, generally we are doing at the scoping of the projects at the process development stage. HS2 we are doing at the process and the project definitions. The HS3 basically we are doing for the project designs. And HS4 we are doing for the procurement and this construction. HS5 is the pre-check for the commissioning. And the final is the operational, which is HS6, which is checking the intent of the modifications. This is the new things I will say, and this is control center risk intelligence. This is simple, I will say, for understanding the risk assessment system for identification of hazard, assessment of the associated risks, implementations of the effective control. And the concept is very simple, is the bow tie. One side is the hazards, others, and then the preventative control. If our preventative control is missing, then incident is happening. And after that, we have to focus on the mitigations control and the major hazards. So this is the new concept for the doing the risk assessment. And job cycle check is very simple things, but very, very important things for checking the effectiveness of the real operation at the shop floor. The main purpose, why we are doing this JCC, to ensuring our job is happening as per the defined procedures, eliminating the hazards, eliminating the variations in our process, establishing the best practices, and encouraging our the people to do the job as per the defined process. And next is the incident management. The incident management, in the today morning session, Mr. Murthy was giving a lot of...
Mr. Rakesh, I will request you to wind up in next 2 minutes.
Okay, thank you, sir. In the morning session, Mr. Murthy was giving a lots of focus on the incident. Yes, in real world, we are not too open to capture all the incident. But when I'm talking about the process safety, when I'm talking about the best practices, we have to develop a culture to capture all the incidents, identify all the deviations in the process, analyze all the deviations, take the corrective and preventative actions so that this type of incident, same type of incident cannot be repeated in the futures. Next is the emergency management. This is also very, very important things. When any emergency is happening, what are the factors we have to take care? So emergency management includes the planning for the possible emergencies, providing the resources to execute the plans, practicing and continuing the improving the plans, training, informing the people, community, contractor, etc., and effectively communicating with the stakeholders in the event an incident does occur. And another important factor is the management of change. Generally, we are missing in the management of change. The management of change procedure defines the requirement to identify and manage the potentials, health, environment, and physical security risks associated with the permanent or temporary change related to the equipment, process setting, even the human beings. So this is very, very important factors in the IS manufacturing as a safe best practices. And the other important stuff is the product stewardship. Lots of focus was given what we have seen in the morning sessions related to the product development, design, development, the manufacturing, transportations. Important factor is the dispose and waste. So we have to always take care while doing the design of the product regarding starting from the concept to the base destruction of that particular product. And these last two slides is basically related to the human being. The first is the competency and proficiency, and which is applicable for competency is applicable for all the employee. And this competency we are defining as a skill, knowledge, and how much expertise you have to performing for a job. And the proficiency is a method for checking the knowledge of the people at the different level in the organizations. Basically, we should give too much focus on the proficiency for the operator, which are doing the job every day. And the last one which is related, I put some challenging questions for the leader. What is my understanding, everybody sitting in this room are the leaders, I will not go through the questions, but these are the challenges questions we should always think in our mind for the leaders. Thank you, sir.
Thank you, Mr. Rakesh Kumar. Mr. Rakesh has made a very comprehensive paper. It's a very detailed one, almost going to 14 to 15 pages. I'll call it a sort of Bible, and I request all the operation area people to go through it in details. It is worth preserving and worth emulating. Thank you very much, Mr. Rakesh Kumar. Now I invite Mr. A.K. Srivastava. His paper is Hazards Involved in HMX Manufacturing. I will introduce Mr. Ashish Kumar Srivastava. He is a postgraduate in chemistry. He has 30 years of experience in the field of explosives and accessory manufacturing. He is working with Solar Industries, Nagpur, since 2004. Currently, he is Senior General Manager Works and as Operational Head of Nagpur Unit. Please go ahead.
Good afternoon, dignitary on the dais and off the dais. My topic is hazards involved in the HMX manufacturing. First, we should know about the HMX. I think for defense purposes, it is well-known figure, but for the commercial, it is a very new concept. The solar industries is the first industry in India. It started manufacturing HMX in the full scale. Still, they are producing in the defense and the pilot plant scales like TBRL and HEMRL. But we have set up a 50 tons capacity plants in Nagpur itself and expanding it to 300 tons capacity. Not only HMX, it is related compounds also like Octal, OMA, Ocfol, NSO30, 304, RDX. And these are all the components we are making. We are started supplying to the defense sectors and for our commercial uses in the shock tube manufacturing. So we have an introduction to HMX, the content, HMX manufacturing process, hazards in HMX manufacturing, guidelines to prevent hazards in HMX manufacturing, comparison between high explosives, and then conclusion. This is a little introduction. Most of the people are aware. Is a high melting explosives. The chemical name is also octogen we are calling. And the cyclotetramethylene tetranitramine is the IPSC name. Is violently explodes at very high temperature. The basic raw materials are hexamine, ammonium nitrate, acetic acid, acetic anhydride, concentrated nitric acid, and gamma-butyrolactone as a solvent. The applications of this HMX is to high explosives composition for warheads, rocket fuels, booster charges, shock tube manufacturing, and cell gas exploration as a commercial purpose. This is the flow charts. It is having a 5-6 operations processes, the nitration of chemicals. Then we had to remove all the unwanted nitrates which is formed during the nitro compounds formed during the reactions, that is simmering. Then we had to do the filtration, remove all the acids with the impurities like RDX from the HMX, then recrystallizations to get the required crystal size of the product, and then it is a final product. Certain important parameters like melting point. This is the advantage of this product because of the higher melting point. The particle size is very important in the application of the military field. Purity, the acidity, RDX content into that, and total insolubles in acetone. These are some of the equipments which is used for testing of these products like FTIR, HPLC, particle size analyzer, and DSC. These are some of the glimpses of the solar HMX plants, if you can see. Now we are coming in the topic of hazards actually involved into the HMX manufacturing. There are two types of hazards, mainly in the physical and the chemical hazards. Physical hazards means flow of material, agitation properties, electrostatic charges, the designs, so on and so forth. Mainly the chemical hazards comes into the picture because it's a very complicated reaction, and I personally come across is most of the complicated reactions pattern into the HMX manufacturing. In PETN, if you add P into the nitric acid, you will form PETN. But here, if there is a difference in the temperature, in the pressure, in the flow, you will find different compounds, which is not at all desirable into the process. Ammonium nitrate, you all are knowing about this. The nitric acid also is very critical compound into that. Acetic acid is dangerous when it contact with the oxidizers. Vapors of the acids are harmful to the eye and lungs. Acetic anhydride is known as a water-reactive, corrosive, flammable liquid. Hexamine is also combustible when exposed to the heat or flame and can react with the oxidizing materials. It is a mild skin irritant, and the side effects are urinary tract irritations, skin rash, and digestive distributive systems. This solvent, gamma-butyrolactone, is used for the recrystallization of the crude PTN, crude HMX. Is well-known inflammable solvent. Its vapor is contact with the flame may cause explosion. It causes skin irritations and headache due to the prolonged inhalations. Hazards involved in the mixing of chemicals during the manufacturing of HMX. This HMX manufacturing process involved heating, cooling in the same process, in the same nitration process. And this is a very critical phenomena to have any molecular explosives, particularly for the HMX manufacturing. In the PTN, you know, only cooling is required, but here in the process, you need to have a cooling and heating system together. As in the case of starting materials, controlled mixing of chemicals can also result in a fire and explosion hazards. The fires at 29 degrees centigrade or higher ambient temperatures are considered to be the result of formation of hexamine dinitrates, which can bring the mixer near boiling, the ensuing oxidations and or decomposition of hexamine dinitrates or its fragments by the excess nitric acids, finally by the exothermic decomposition of ammonium nitrate. These are the reasons why there is an explosion or there is some fume off system into the nitration. Hazards due to the crude products, unstable polymeric forms of HMX, forms of alpha HMX, we require beta HMX into the systems, so alpha HMX is very sensitive. Other hazards, the guidelines for this, the maintenance and repair works is very important aspects into the process of any nitration or any molecular explosive manufacturing, preventive maintenance and proper repair works, the permit systems, operators' presence and alertness. You need to have a lot of alertness by your process operators because the parameters go on changing and you have to control the systems. So that's why this parameter is very, very important apart from the knowledge. Sequences of addition of the materials during nitration you cannot change. If you change something else, you form something else. So sequence, when you are adding the first solution, when you are going to add second solution, what is the time dilution is required, what is the difference between one to another quantity is required. The sequence is very, very important for the formation of good quality of HMX, pure HMX. Inspections, so maintenance schedule is required, sprinkler testing is required, safety equipment has to work properly, so preventive maintenance of these systems also important. Leakages we had to see, water hoses in the plant's area. The other is the cleanliness orders. Floor should be always flushed properly, no dry floor. Containers for transporting explosives to and from the plant, it is very important aspects. Equipment and material in plant, spillage of flammable explosives in the process area, spillage of explosive as well. Safety from design, it is important to know the process hazards while you are designing any plant. The building design, the equipment design, the agitation system, the cooling effect, the heating effect, these all are the very important parameters while you are designing a plant. Normally what is happening, people design the plant, put the plant, and then start doing the hazard study and risk assessment. And that time, most of the time, people are leaving behind many of the hazards. It is already into the inbuilt system. So wall design, bent inlet pipes design, hollow structures, ventilation of reactors, layout and placing of the equipments. Managing risks with the thermal stresses like temperature controls, time factors, management of risk for pressure burst. You have to have bursting discs, ventilation valves, pressure in pipelines, the control systems, and the release system both are required. Management of tank form area, because you are going to keep lots of flammable materials like nitric acid, acetic anhydride, acetic acid. So the management of the tank form area is very important. A person should not unload nitric acid into the acetic anhydride tank and acetic acid into the acetic anhydride tanks, and this is a very different reaction form. So it's very important to control the tank form area. The color codification, the interlock systems are very important there. Escape routes, you know, for any explosives plant, this is very essential. Doors, running lanes, level alarms, windows, ventilations, with all the things. The interlocks in any explosive is very important, but here in the HMX manufacturing is much more important, because if you don't control the temperature, you may form RDX, you may form other compounds into the same reactions content. The earthing systems, for all sorts of earthing. UPS system in the first, I think Gupta ji was telling about the generator required for making propellants, but it is better to have the UPS system into the system to control the operations if there is any power shutdown. So we have all the UPS system for controlling all major interlocks, the major parameters of the process, the major equipments like agitators, the branch circulation or the heating effects, the air, like that. Competency of the operators and engineers is very, very important aspects. Untrained manpower can do much more hazards than the trained manpower. You have to know the startup process, the shutdown process is equally important. You cannot leave aside any hazardous material into the process. The knowledge, the chemistry of this HMX, the chemistry of the raw materials used into the process, bit knowledge about the instrumentations, these are all factors important, and that's why the engineers has to be very competent enough to run this plant. The training is a very running process. In fact, every time you have to put something new to these systems, and your operator should be aware about that. The HAZOP study, all the 6 stages you have to do from 1 to 6, and if there is any changes, it has to be another hazard studies required for that. And accordingly, you have to do the risk assessment and make the mitigation plan for all the risk involved into the processes. The hazards identification and risk assessment, you have to always identify the hazards by the means of your